All right. The nice thing about this is the right triangle trig is a lot easier to deal with than the circular stuff. So, what you really need to have this time is this nice little figure here with the triangle. Make sure that you've got those in your notes and that you have access to them, because that's going to be one of the things that we're going to run across to almost all the time. Okay. So that one, and a couple of little things that are kind of handy to have is this complementary angle steer. Now, you've probably seen this already when you're looking at the circle stuff, especially when you're looking at the coordinates, because the sine of 30 was the same as the cosine of 60. So you're going to be able to see those things a little bit easier now. Okay? So again, just kind of things to keep in mind. Now, we were using this before, sine squared plus cosine squared is equal to 1. But now we've got it here for the right triangles. C squared is equal to a squared plus b squared. Well, you should recognize that as the good old Pythagorean theorem, right? Mm-hmm. And of course, a plus b is always going to be equal to 90 degrees for right triangles. So let's see, if I'm not mistaken, we've got just about all of the stuff that we need to play with these things. Now, a lot of these are going to require you to actually draw something out. I'm not going to go over number 1 here. That's fairly simple. But let's take a look at this one here. Okay, so it says the rain gutter is to be constructed of aluminum sheets 12 inches wide. Okay, after marking off a length of 4 inches from each end, the sides are bent up at an angle theta. Now, they've got the picture there for you to go look at. You can go and do that. But again, I would definitely go through and take the time. Just draw yourself out a picture of it. It gives you a pretty good idea of what's going on. Okay. Mind you, again, it doesn't have to be exactly perfect, but it just has to get the job done. Now, we know that this is going to be 12 inches wide, and we know that it's 4 inches from the end here, so this turns out to be 4 here. This is going to be 4 there, so this has to be 4 there. Okay. Now, they want to express the area A opening. Now, let's just say we got the triangle set up like this, okay? Or not the triangle, but the gutter set up like this. What do we really got? Well, got a line going straight across here. Yes, I know. It's just the way life goes. Yeah, that's better. Now, okay. Now again, your angle theta is here because that's what it's being bent up at all the way across here, okay? So there's your theta, bending it up. Now, of course, they've always got a prettier picture there. Now, I see what they did. Their theta is coming up this way, as opposed to what they are bent up at an angle theta, bent up. Okay, not a problem with that. Always good chance to read. So, bang, bang. So, no, don't do that. So, there's our angle theta. Okay? Which makes sense because it says it's bent up. So, the thing is, this is going to be parallel to that, so I also know that this is going to be theta up here as well as up over here, correct? So we know we got two things going on here. We've got two triangles, okay? So we've got triangle, which is base times height divided by 2, right? So base you could think of as up here. Height you could think of as being down over here, right? Now for the rectangle, that's just going to be 4 times h, correct?
Mhm.
And this height here is always going to be based upon what this is. What's up?
My computer is like, or I'm just being dumb. I don't know.
No, you're not being dumb.
Okay.
Okay.
I'm trying to find the first X or whatever, the first 0 that you find, and I can't get it. It keeps
Okay.
on saying error bound.
Oh no. See, this is what they were talking about here. This does not intersect with the x-axis at all, right?
Mhm.
So that means that there is not going to be any zeros for this.
So that means the first X is going to be 0?
No, that means that that this is going to be equal to 0, and then you got to use the quadratic formula to solve.
Oh,
Okay?
that's fun.
And you're going to get an imaginary answer. It's all fun.
Imaginary numbers.
It's all fun. So what we need here is we need to know what h and b are going to be. Okay? They're fairly easy to figure out because we know that the sine of theta, which is right here, is going to be equal to SOHCAHTOA, opposite, which is the which is h here, over 4, correct?
Mhm.
Now, we've got that piece of information. We've also got the information about what else can I set h equal to? I could also say that h is going to be equal to the square root of, let's see, 4 minus b squared, okay? Pythagorean theorem. Okay. So I can do that as well. Which way was going to work better for us? What's the best way of attacking this now? Okay. I can also, can I write b in terms of h? I could also say that b is going to be equal to the square root of 4 minus h squared, right? I could also say that the cosine, cosine of theta is going to be equal to b over 4. So it really boils down to what's the best way of trying to deal with this stuff. How do you want to attack it? Okay. But the more information that we've got, the better off that we are. So far so good?
Mhm.
Okay. So, the other part of this thing here, which one do you want to try solving for? Would the square roots seem to be an easy way of going, or sine and cosine?
Sine, cosine.
Sine and cosine would work out really well in this case. Okay? If I had one of these other numbers here, then I'd plug it in here and figure out what's going on there. So that's a good thing. Because what I can really do here, because we're supposed to have this as a function of theta, I can rewrite sine as 4 sine theta is equal to h. I can rewrite 4 cosine theta is equal to b. Does that make life a little bit easier?
Mhm.
Okay. And we know that this is going to be 1/2 of the base times the height. Okay. Since we got 2 of these here, we can kind of cheat a little bit and say, well, that's just going to get crossed out with that, right? Because we're looking at the area of this. We got 1 here, got 1 over there. So it's really just going to be base times height. Okay. So I'll extend this out a little bit more. So that means that I end up having 4 sine theta multiplied by 4, oops, sorry, multiplied by 4 cosine theta. And that pretty much takes care of the triangles, right? So, what about the rectangle? Well, rectangle, that is just going to be plus. That's going to be 4 multiplied by what? 4 sine. Okay. So, what we really end up here with is going to be, well, let's see, if I multiply that out, that's going to be 16 sine theta cosine theta plus 16 sine theta. Now, we could just simply do this, make life a little bit easier. 16 sine theta multiplied by cosine theta plus 1. Okay. And there we got it. So that's the equation that we're looking for now. So we got that. Now it wants to graph so that we can find the largest. So we want the most flow, so that's going to be a maximum. So what we would do then, grab the graphing calculator, and find out where the maximum is going to be. So we got second, reset it, second plus so y is going to be equal to, we said 16 times sine theta multiplied by cosine theta plus 1, close it. Now, what is theta operating in this time? Is it radians or degrees? Degrees. So we got to make sure that we go over here to the window or mode first. Change this over radians, move it over into degrees. Enter. Change the window because we don't need any zeros there. Maximum number of degrees, well, that would be 90, wouldn't it? If it was straight up. Okay. So, y minimum, well, we can set that at 0. Maximum, well, let's see, it should be more than 16, so I'm going to go up to, oh, let's go say 25. And graph we do. Okay. Goes up, goes up. Okay. So, second, calc, move over to maximum. Left bound, we can move it over a little bit here. Enter, right bound. Over there. Yes. Maximum. I got 60 degrees. Did you change it over to degrees?
Yeah.
How'd you type the equation in?
Probably wrong.
Okay. You got 16 multiplied by the sine of x multiplied by the cosine of x plus 1. Sometimes it's really, 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 really handy to keep the... Okay. Bring me your calculator once, because that doesn't make any darn sense.
How do you know to change cosine plus 1?
Oh, because you're factoring out. Because if you look down over here, this was 16 sine cosine plus 16 sine. When I factor out the cosine, think of it as a reverse of the distributive property.
Oh, yeah. Yeah.
Count maximum. Enter.
Could you just leave it the other way and still get the same thing?
Oh, I see your parenthesis here is the problem. Because your parenthesis, you're putting the 1 inside here. So when you're looking at this, what you should really end up having here is going to be, this has got to be the parenthesis out here. Okay. Delete this one here. And now when you hit graph, it'll do it correctly. Yeah, because you had the parenthesis in the wrong spot.
Can we borrow your computers for science?
Yeah, go ahead. So, that makes sense. Alrighty, let's try something a little bit more interesting. Okay, let's try, you're solving out a basic right triangle here. Well, I want us to use the figure, so we'll end up grab that as well. Make life a little easier. Okay. So, we know that B is going to be equal to 2. A is going to be 40 degrees up here. Now, a lot of times what they'll do with this stuff is your capital letter will be identifying what your angle is. The lowercase is going to be identifying the side opposite that angle. So I want to find out what all of these are going to be. Honestly, it doesn't matter which way you want to go. How do you know that? Okay. Most definitely. So we end up getting 50 degrees down here for B. So it doesn't matter. How do we want to go through and find out what, say, C is? Okay. So that means I could use, let's see, I could say the sine of 50 degrees is going to be equal to 2 over C, right? I could say that the cosine of 40 degrees is going to be equal to 2 over C. Does that make sense?
Mm-hmm. Can't you use the same one? Like, can't you just pick any one?
Yeah.
Couldn't you do cosine 50 equals whatever?
Okay, if I wanted to do cosine of 50, then I would need to know what A is. Okay. I could, if you want to find that, you could use tangent of 50 degrees is going to be equal to 2 over A. It really doesn't matter which way you want to go with this stuff. So now, generally when I'm talking about these things and I want to simplify them, I kind of told you about the deal before. You multiply the numbers that are diagonal to each other and divide by the other number. So it's rather than redoing the algebra, it's just going to be 2 times 1 divided by the sine of 50. So really what we're looking at here is going to be just going to be 2 divided by sine 50. Okay, well, I get 2.6. Same thing if I did cosine. It would be 2 divided by cosine of 40. And they should be exactly the same. And they are. Okay. So the thing is, if I wanted this, now you'll notice that there's a whole boatload of numbers that are still going out behind the decimal point here. This is where we get a little error coming in when we're dealing with the trig. If I do that, if I were to say just round this to 2.6, I am going to get a completely different answer than if I use this. So say, for example, I now want to go and figure out what A is, and I decided, hey, I want to use the Pythagorean theorem. Okay, so that's going to be this squared minus that squared is equal to A squared, right? So what I would do is I would keep this in the calculator, and I would go second squared, whoop, wrong way, clear, I messed that up. So let's go back, 2 divided by sine 50, close it, enter. Now I want to raise that to, that didn't work very well. Now I want to raise that to, so it's going to take that answer to the second power, okay? Enter. Subtract off 4, enter. Raise this to the 0.5 so I can do the square root. And now I've got the full value of A.
You get 4.
Huh? 2 squared.
Okay.
So now if I really wanted to, I could have also done this and done the tangent, which would have been, come on, grab onto that, which would have been 2 divided by tangent of 50. So I could have taken 2, divided by tangent 50, close it, enter, and I get the same exact answer. So there just isn't one way of doing to it. It's just whatever's the easiest way to go through and figure out what is going to be what. Now, let's see. Let's take a look at another one of these wonderful problems, but we're going to try something a little bit and try and apply one. Let's see. There we go. This looks good. Finding the height of a cloud. Okay. Now, pictures here are going to tell you 1,000 words. Okay. Meteorologists find the height of a cloud using an instrument called a celiometer. It consists of a light projector that directs a vertical light beam up to the cloud base and a light detector that scans the cloud to detect the light beam. Okay. Now it says at Midway Airport, blah, 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 was employed to find the height of the cloud cover. It was set up with its light detector 300 feet from its light projector. So, now mind you, whenever we draw these things out, we always assume that we're starting with straight line, right? So, clouds are up there. Never said it was a good picture. Now, they've got two things. They got a light projector and they got a detector, right? So, projector and detector, right? Now, it says light projector that directs a vertical beam of light. So can the projector be here? Nope. These got to be switched around. So always helps to go through and read, and the detector is over here. Okay. So we've got the light. Let's see, going straight up, right? Light is going straight up. Detector is going through and trying to detect that, right? Okay. So now, let's see. We know that the light detector was set up 300 feet from the projector, so this is going to be over 300. Okay, we knew that the elevation of the base of the cloud was going to be 75 degrees. So this here is 75 degrees. Okay, and what we're looking for is the height. So which one is the most beneficial to use here? Well, I could care less about this distance here. So setting this up as tangent of 75 degrees is equal to opposite over adjacent, h over 300. Now, if I set this up as a ratio, I know that I got to take 300 times this tangent of 75 degrees, divide by 1, gives me h. So, grab a calculator, and we just end up going to, we end up tangent, yes, 75 degrees, enter, multiplied by 300. Okay, so I end up with 1,119.6 feet. So now we wouldn't necessarily want to be that accurate. We would just say that the height, height would be equal to 1120, because after all, I mean, you're going into the clouds, so there's a little give there. Okay, that makes sense?
Yeah, this stuff is so much better.
Oh yeah, this stuff is a lot easier, but again, draw out the picture and it'll make life a lot easier for you. And that will be that.